moments of 2D forces using Casio FX 570ES or 991ES Plus second edition. Now, this calculator technique is, I am proud to say that it is my self-developed calculator technique. So I just developed this over the last month, and my objective in developing this calculator technique is, what if there is another way of calculating the moments of 2D forces without using components or without using vector mode? So that's what I am thinking in developing this calculator technique. So I will show you how to use complex mode in calculating moments. In this example, we are asked to calculate the moment of the resultant of the force system shown in the figure. So right now there's none, but I will show one by one the forces that we will be calculating. So first, we will enter the mode 2 or the complex mode. So mode 2. So we are now in the complex mode. Next, let us now show the forces. So first, we have this 30 kilonewton force. So angle that 20 degrees from the horizontal. And then the tail of the vector is 2 meters from the y-axis and 6 meters from the x-axis. So the coordinates are 2 and 6. Now, manually, you can use the Varinon's theorem to decompose the force into components and then get the components moments one by one. Or you can use the vector mode to calculate R and calculate F, and then use R cross F to calculate the moment and then get the Z component, since that's what we are desired. Now, if we use the complex mode, what we will do here is, first, we will input the force. But there's a twist. Since in the calculator technique, we input first the magnitude, and then the angle symbol, and then the direction. In this case, it's 20 degrees counterclockwise positive. However, for the purposes of moments, we will subtract it from 180 degrees. So in this case, the input will be 30, angle 180 minus 20 degrees. So this is kind of artificial, but it is essential in this calculator technique. So let's input 30. Let's input parenthesis just to be sure. So 30 angle, and then 180 minus 20. So we have now inputted the angle and the direction and the magnitude. Next, how do we input the distance of the tail of the vector from the point with which we want to calculate the moment? In this case, the origin or the point O. So we will input these coordinates in terms of complex number. So we will do that like this: 2 plus 6i. So 2 is the x coordinate, and then 6 is the y coordinate. So let's input 2 plus 6i. Again, pressing the N key to access that imaginary number I, and then close parenthesis. So that's for the first vector. Now for the second vector, so let's add it. So it's also a vector sum. So let's add. And then for the second vector, so we have a 50 kilonewton force, angled 40 degrees clockwise from the horizontal. So the coordinates of its tail are -5 meters and -3 meters. So usual, let's input the magnitude 50, and then for the direction we will use -40. So again, counterclockwise is positive, so clockwise is negative. So in this case, it's -40 degrees. But then for the purposes of moments, we will subtract that from 180 degrees. So we will input 180 minus -40 degrees. So let's input that. We have 50, and then angle, and then 180 minus -40. You do not need to input the extra parenthesis here because it's understood by the calculator. So let's leave it like that. Next, let's input the coordinates of this point or the distance from point O. as a complex number. So let's input negative 5 minus 3i. So negative 5 minus 3i. Again, pressing the eng key to access that imaginary number I. Now, if we press equals, so we're done with this. If we press equals, you will see that there are two components, no, as usual, since this is a complex number. So this is the output. However, for the purposes of the calculation of moments, we only need the complex number part, or this one, 126.98, and that represents the moment of this resultant. And that is the final answer for this problem. Now, you can leave it like that, writing the answer directly. However, if you want to use this value as a necessary number for further calculations, all we need to do is to extract that number from this complex number. So to do that, we will use the formula answer. So the answer is the previous complex number in our calculation, and then minus conj g, or the conjugate of that answer. So by conjugate, meaning we will change the sign of the complex number or the imaginary part and then retain the sign of the real part. So if we have a plus bi, the conjugate is a minus bi. So that's what conjugate is. And then we divide that by 2i. So again, it's very artificial, but it's essential for the calculation. So to do that, let's press AC, and then let's input that expression. So we have answer minus conjugate. So to access the conjugate function, we press shift and then 2. So to access the complex number options, and then we press option number 2. So option conjugate, and then we press answer again, and then we divide by 2i. So that is the entire expression. If we press the equal sign, you will get 126.98. So we have successfully extracted the complex number part of this number. So and that is the final answer for the moment of the resultant. So that's it for the 2D moment using Casio calculators. So hopefully you got something from this new method, I think. And that's it for our video. I'm Engineer JD, and see you on the next video, mga Ka-Casio Nation.